All right, so again, welcome everyone. Thank you for joining us again on another episode of our learning series. On today's episode, we have two guests joining: Dan, the CEO and co-founder of Cinchy. So welcome Dan and Kevin to the learning series. Dan and Kevin will be sharing with us their innovative geoimaging solutions that is simplifying science for business. They're going to share how Data-Centricity has enabled their solutions and have made it possible for them. Regardless of what industry you're in, I do believe you'll find this session fascinating, and you'll find the impact of geoimaging and data centricity applicable to what you do as well. So before we jump in, I'm going to take a moment just to introduce Dan and Kevin today so you can get a little idea of who they are. Okay, Dan Watt is the CTO at CATALYST, a PCI geometrics brand, which seeks to simplify access to Earth data. He's responsible for technical direction, specifically the new delivery methods for the mature science the company has developed over the last several decades. Dan has a long history of creatively using technologies to improve processes and disrupt businesses. He started his career as an entrepreneur and moved into the world of finance, working in several positions at two of Canada's largest banks, mostly in global projects. He comes full circle back to his entrepreneurial roots as a key force behind the major pivot implemented at PCI Geometrics with CATALYST.Earth. Kevin Jones is the Vice President of Product and Marketing at CATALYST. He's responsible for the strategic alignment of new product introductions and growth in new key markets by leveraging CATALYST's powerful sensory agnostic, Earth image processing science. Kevin has worked in private industry with Earth observation sector throughout his career. He has extensive experience across Earth observation value chain, having worked for data providers, software and tooling providers, and now the delivery of analytics to downstream end users through CATALYST.Earth. Before I pass it on to Dan, please feel free to ask questions throughout the session. I will be monitoring the chat. Over to you, Dan.
All right, thank you, Fatima. And welcome, Dan and Kevin. Dan, love your name. We should have a session where we can have 3 or 4 Dans. That would be fun. Welcome to both of you. And what I'm going to start off is just a refresher for anyone who may be joining us for the first time on what the heck we mean when we talk about data centricity and data centric, just to set that context before I hand it over to Dan and Kevin, who are going to show you something really, really cool. But the idea of app centricity is how we've architected technology for 40 plus years, probably approaching 50, where there's an app for everything and a database for every application. In this model, if you have 500 applications, you have 500 silos, and that's way too much integration that you need to do. And it's somewhat agnostic to if it's monolithic versus client server versus 3-tier versus SOA versus microservices. It's the same pattern that we've been doing over and over again. And while it enables fast delivery, you pay this integration tax that today consumes half of the budget. And that's what data centricity is really all about. It's a major shift that is been talked about for, I say, several decades, but it's never really been real. But there is the new emergence of technology, largely driven by the proliferation of applications and SaaS. But in this model, the data doesn't get owned by individual applications. The applications simply provide experiences into the data, kind of like how you separate buildings that need to consume power from the power grid, which manages the generation, distribution, storage of power. Whereas in the traditional model, every building had to generate its own power. So that's the idea of data centricity. In this model, whether you had 500 applications or 5 million applications, the number of silos and integrations remains at 0. But that's an altruistic vision of a data-centric future. The reality is that you get there iteratively, kind of project by project, case by case. It doesn't happen overnight. Today we're going to see an example of how data centricity can be applied in a really fascinating concept that I really enjoyed getting to get visibility into in terms of working with Dan and Kevin and team. And for those who maybe haven't seen a data-centric experience, what you're seeing is the result of us actually, after about 2 years of using a data-centric methodology to run our business, where we essentially have visibility into all of our company's knowledge. It's organized around domains. So if any of you follow the recent trends around data mesh networks, around establishing data as a product, where a domain is really a governance boundary, and then what you're seeing is our various domains that we've evolved over the past couple of years, and being able to really ask any question, get any answer instantly, and data's at your fingertips, but you never give up control. And one of the things that I've noticed that this changes is, if we think through the past number of decades, we've been delivering technology systems for quite a long time, but it's like there's been a fog of war that prevents visibility into the data, that limits your intelligence. But as new innovation comes out, it's starting to blow away that fog. So, there was a point where we had the realization, I don't know, 20, 30 years ago, of the value of internal data, our own operational systems, and being able to centralize that and provide analytics on top of that to, cross-sell, upsell. And then the emergence of social media gave a whole new data source that started to, again, expose what was previously a blind spot. So that organizations who were able to get a handle on this became more intelligent. We're able to use that to reduce risk, to drive up revenue, and basically put that data to work. But it required you to have the capabilities to gather the data, organize the data, and analyze the data. Other external data sources, and this phenomena keeps continuing. So it's hard to know exactly what is the exhaustive list of blind spots. I'm sure we have not cleared this fog completely. Location data, weather data, and today we're going to go into what for me was a big blind spot, and this experience really opened up my eyes. So I'm excited to have the guys walk you through it. But it's around Earth data, and that's where I'm going to hand it over to Dan and Kevin, and walk through the Catalyst Insights platform and how they've applied data-centricity.
Great, thanks, thanks, Dan. I'm going to ask for the next slide. I'm not driving the slide deck, but here we go. Yeah, so really the insights that can be extracted in terms of Dan refers to a blind spot. I think there's a real opportunity for Earth data to be leveraged for multiple industries. And some of the industries are listed there where Earth observation and Earth data can be applied to derive benefit. Some of the benefits are listed there in terms of revenue generation, risk mitigation, cost savings, or strategic planning. And one of the key things that we have been working on is to take the science that we've been developing for a number of years and to simplify access to that science. And just if I can have the next slide. The work that we do at Catalyst is to eliminate the situation that you may have experienced in the past if you thought that satellites were cool and you thought maybe it'd be great if I could extract information from satellites, but then you started to get into it and you realize that it's quite a number of steps. There's data searching. There's literally hundreds of satellites that are orbiting the Earth and collecting data on a regular basis. You have to download that imagery, you have to process it, you have to represent it and make meaning from it and ultimately disseminate it. And even if you were to do that, typically this is in the realm of the experts in terms of remote sensing science or Earth observation science, and they might produce an information product which is meaningless to the business user. The business user might not know what a ground deformation movement of 3 millimeters per week actually means to their decision-making process. So when we're looking at a very simple question for that business user, what is the risk level to infrastructure? What we have been busy doing is to leverage all of the science that we have developed and to make it more easily accessible. Our tagline is Earth Data Simplified. And what we provide is actually an interpreted product that tells that business end user what the risk level is to that critical infrastructure. So I'm going to give a live demo and walk you through this application. On the left, basically what you'd be doing is downloading imagery, using complex software, performing advanced analysis. Really this is for the expert user. On the right, anyone can use it. So I'm going to share my screen. And
Kevin, one quick question for you. My background, as you know, is in financial services. And I know this has applicability into pretty much every sector with some creative thinking. But in a financial services context, what would be some examples of how you could put this capability to work in terms of like a real business impact, in terms of reducing risk or driving up revenue?
Yeah, so one example might be, one classic example that's used quite a bit, that's easy to understand, is car counting. So there are algorithms that can be deployed on Earth observation imagery that gets collected on a regular basis. And there's actually been a proven relationship between the volume of cars in parking lots in front of businesses like Walmart and the relationship of those car counts with the stock price. It's a good predictor of what the stock price will be. Obviously, it gives you an indication of how many people are shopping at Walmart. So that's a very, very simple example of how you can actually leverage multi-temporal, because remember, these satellites are orbiting all of the time. They're always collecting data. So you could produce a car counting product, on a daily basis or weekly basis. The volume of data and the number of satellites is just getting bigger and bigger. So that's a very tangible example that probably anyone can understand.
Very cool.
Yeah.
So for the sharing, do you want to take over and share on your side, and I'll stop on mine?
Yep. Let me know if it's working. Should be working now.
Yep.
It's good.
Yeah. So this is essentially a very simple access to that type of information. So in this case, a business end user, utility management company, would be interested to know if there's a critical risk to their infrastructure. What we're looking at is a map of Tulare County in California. And the color coding is very simple to understand. You can see that there's areas that are red, areas that are green, areas that are yellow. And when I hover my mouse, it tells me how much the ground has moved over the course of a certain time period, in this case, about 1.5 years. And so we can continually monitor using satellite imagery how the ground is moving up or down. And this becomes really important for monitoring critical infrastructure. For example, what is the risk to that infrastructure failing over a particular location? And I'll just zoom into a particular location where we've triggered an alert. So the system that we can provide access to, the CATALYST Insights, which Dan is going to go into more detail, can trigger an alert if a critical ground movement has occurred that's potentially dangerous for that infrastructure. So you can see that utility grid, that blue line, ends on the doorstep of a substation that's providing power to this large industrial customer, in addition to all of the neighboring residential areas. And so if this ground deformation, this movement compresses the pavement down, it could actually cause damage to the utility grid, and that would cause a failure. So, now all of a sudden people have no access to electricity, and that's a problem in terms of revenue generation for that utility, but also in terms of productivity for everyone that lives in this area. And so rather than show the actual imagery, what we represent the information as is risk level. So you can see the risk levels here to the different road segments. And we can also show the representation of the risk levels to specific parcels. So if I turn on the parcel layer, you'll see the different parcels have been mapped to show what the risk level is. So this is a piece of information that a business user can define. If the ground moves more than X, I want to know, because that's going to have an impact on my business. So really it's about simplifying the access to the Earth data through a simple to use web application like this. And we can also push this information out via an API. And Dan's going to take it from here.
Super. Okay, let's move to the next slide. So the question becomes, how do we do all this? The science is complex, the information is complex, and as Kevin mentioned, it's also growing. So the number of satellites that are currently orbiting the Earth is increasing, and it's largely due to the commercialization of space. So the cost to build and launch satellites has decreased significantly. And it's been reported now that there's over 200 startup companies that are projected to launch about 25,000 satellites over the next 4 years. And that's compared to the less than 9,000 satellites that are currently orbiting the Earth today. And those aren't all Earth observation satellites, some of them are telecommunications, but you get the kind of growth that we're talking about. Add to that, the sensors that are on these newer satellites have higher resolution and they generate more data than they did in the past. So we have an exponentially growing data problem in this space. And that's not the whole story though. A satellite can only transmit data to the ground when it sees the antenna, which is what we call the ground receiving station. And it can only see individual ground receiving stations for about 7 to 9 minutes. So there's a lot of them scattered all over the planet. And moving data is time consuming and expensive. So the data really gets scattered across a number of geographically dispersed data centers. So now we have this exponential data growth problem, and it's distributed across many locations. Not all satellite companies are going to be using the same cloud provider. And so the data is also across many cloud providers. CATALYST.Earth, we support many different satellites, and we need to keep track of the data that they're producing so that our clients can get the most recent data when and how they need it, so that it's relevant to the problems that they're trying to solve. So the problem that Kevin was showing was one of ground movement for a utility company in a particular area. But that can happen in all kinds of different places all over the planet, and they don't always use the same data. So this data-centric model provides the scalability that our clients need to provide low cost and low latency data. So with that, let's go to the next slide, and I'll take you through a little bit of the process of how this happens. So at the center of this process, we're not going to go through the entire process. It's actually scientifically pretty complex, but the important parts start at the beginning or at the middle. And so we have something called Catalyst Insights Intelligent Mesh, and it's powered by Cinchy. And Cinchy's product does 3 things for us. First, it exposes the geographic mapping models that are in the underlying database, and that allows us to index all of the imagery and all of the non-Earth observation data to the same locations on the planet, and effectively links what seems to be disparate information in a way that we can now relate it to each other. So you saw land parcels in the demo, you saw streets, you saw an electrical grid, and then overlaid was all this satellite imagery, and then the radar interpretation of that to show the ground going up and down. Secondly, it allows us to track all the data providers that we support and the new data that's arriving from satellites, and then ultimately triggers a process that you see, this 10-step process that provides that information. And so that's very key for us. As we just said, there's a lot of data. It's now scattered all over the planet. It's in many different cloud providers. Something has to keep track of all of that so that we have a single place to go to kind of figure out what we need, when we need it, how we need it. And that's what the intelligent mesh and Cinchy does for us. And then lastly, it provides an API access to the data that we need to expose to our clients. Kevin showed you a visualized version of what that data looks like, but some of our clients already have their own visualization tools, or it's going to feed into an AI routine. As you can imagine, you saw Tulare County here, but somebody might say, well, I want to see an entire country. Well, if you're looking for individual patterns or problem areas or opportunities across an entire country, you don't want an army of people trying to interpret all this data. So often what will happen is we'll feed an AI routine that'll go and scour that information on a regular recurring basis. So API access to data becomes pretty important. So as you can see here, there's a number of steps in the process of taking raw satellite data and transforming it into actionable information that can be used by our business decision makers. And the intelligent mesh, which has Cinchy at its core, helps us orchestrate that process. It involves complex science that both CATALYST.Earth has and third parties, and it uses data from many disparate sources, not just satellite sources, but if you look at step number 2, It also includes non-Earth observation data. So it's a very complex data model. And when you put all this together, we provide low latency data and analytics that provide actionable information to business decision makers that help run their business. And that's the power of data centricity.
So Dan, just so I can play it back in my own words, just how it works is, so you have all the satellites gathering all the images and storing them scattered all over the planet, essentially.
Pretty much.
And these are massive files because they're very high resolution and there's a lot of them. So you can't just move all that data. Anyone who wants it gets a copy of it. That would be way too much. So the idea here is that the platform is providing the intelligence extraction from where the data sits, and then disseminating the intelligence, the interpretations, as well as making the raw data available on demand. But it's the enablement of, like, the centric part of it is the centralization of the intelligence, which can then be used, like the output of that can then be used as an input into a business process. Maybe I'm trying to figure out the potential impact of Earth change or Earth future predicted changes on the value of a house, or should I issue this insurance policy, or whatever the business context is. Do I have that right in terms of what it's actually doing?
Yeah, so we always start with that define a problem. It's at the bottom of this slide. And so it is very much around whatever the client's problem or challenge is, opportunity, you can call it what you want from that perspective. So if it is, about counting cars, or it's about mortgage credit risk, or it's about, from a financial perspective, there's several things that it can certainly be about, then that's the data that we bring to bear. Because the data is scattered all over the place, and let's use some sort of real examples in terms of what we're talking about here. The image for Tulare County, just one image, and we processed 1.5 years worth of these things, but just one image would be about 7.5 gigabytes. So you don't, and that's just one. So if you were doing a whole country, you can start multiplying by hundreds. Just one of our providers for the information that we were looking at today has 27 petabytes of data just for that satellite. So you can't just move 27 petabytes in any easy and fast way. So what we do is we take a microservices view to this. We've split up all our algorithms into modular components, and then we can deploy those algorithms at the data center where the data is existing. So to do all that, though, we need to know where the data is. We need to know if it's an area of interest that we need to know a lot of the details around the data. And that's what the intelligent mesh does for us, so that when we see a new Tulare County image that comes, and they come about every 12 days for that area, when it shows up, we get notified that it's new and available. We can then go process it, and where we're processing that right now is in Europe. So instead of moving the data from Europe to North America so that we can process it, we actually have a fairly small algorithm that gets deployed in Europe, processes that data, and then brings it back for visualization. Actually, just the visualization piece gets brought back to North America because the users for that are in North America. But if the new users were in Australia, we would move it to a data center in Australia. We always look at the next step in the process to say, where's the data best located for that particular experience.
Right. Very cool. And so I remember the first time I saw the demo, I was in awe. I had never seen anything like that before. And but is there a way that people can try it just to kind of experience it?
There is, Kevin.
Yeah, so the application that I demonstrated is actually completely open. It's available at insights.catalyst.earth. It's open, it's open. You can go there and log on and try it yourself. I do recommend that you get in touch with us to see how this particular scenario works and how it might apply to your situation. So we'd be happy to do that.
Excellent. So I guess before we close though, we would definitely want to open it up for questions. So thank you both for joining. Fatima, do you want to just quickly introduce the coming up sessions, and then we'll open it up for Q&A?
Absolutely. So next week, be sure to join us for a conversation on why digital economy is bracing data-centric companies. So Dan, our CEO, will be joining Ruben Sardarian, CEO and owner of Infocratic and former database and business intelligence leader at Questrade. So be sure to scan the QR code to register yourself for that session. We'll also be at the Big Data and Analytics and CU-Lytics this month as well. So we'll be talking with Concentra on March 25th about their data-centric approach. You don't want to miss it, so be sure to register, look out for more information in your inboxes. I'm going to just pop over to the chat now and see if there are any questions in the chat window. Alternatively, if you'd like to come off of mute and ask a question to either Dan, or Kevin, please feel free to do so now.
So Fatima, I do see a question from Craig.
Yes.
Dan or Kevin, do you guys want to take that? It's to what extent are the systems data agnostic, and does it have any impact on accuracy?
Yeah, so that's probably a question for us relating to the demonstration that we gave. It's a bit more of a technical question on the sensors. So the system is absolutely data agnostic. We chose one particular source of data for that demonstration that is openly available from the European Space Agency. But you can absolutely substitute other types of data. And really, it's a really good question for this audience because there are many different types of data out there, satellite data, and they're not created equally. There are different resolutions, both spatially, so how much detail you can see on the ground, but also temporally, how often they revisit. And depending on what application you want to use the information that you can extract from, you might use a different source. But the workflows that we have are agnostic, so you can substitute the different data types.
There's another question there around what other applications could be real game changers. Agriculture often comes up. Farming's gone high tech. So, you know, when we look at agriculture in the past, you know, you planted the seeds, you watered them, they grew. Now you can keep an eye on how your farm is progressing. We can tell you when it needs to be watered. We can tell you if there's certain infestations in terms of insects, what kind of pesticides you would have to put where on the farm. So when you get to these really large farms, it's not really about watering the whole thing or using insecticides in every aspect of it. It's too expensive to do it that way. So it's like a micromanagement of your entire farmland. We can also do crop yields, so you know how things are progressing. There's an insurance play on that. Often farms are now insured in case of you know, catastrophic things like hailstorms, hurricanes, and things like that, flooding, and often earth observation data is used in those insurance claims. So it really does span the gamut, right from agriculture right through to the financing of agriculture. You know, what areas of the planet are best for certain kinds of crops, and how much money will be lent to a farmer to be able to grow, and all that good stuff. It's pretty interesting.
Wonderful. It is noon, so I do want to be mindful of everybody's time. There is one final question in the chat window. So I just want to ask Dan, and Kevin if they have a couple extra minutes to answer that final question, and then we can wrap up our session for today. So Dan, and Kevin, do you have an extra couple minutes?
Sure.
Okay, wonderful. So the question is similar to Dan's question, a scenario of change for city engineers to get data they didn't get today. So I guess it's similar to the other questions that you guys just answered to say, hey, is there more way for city engineers to get similar data for them as well?
Yeah, I think what changes here as we simplify the access to this Earth data is that these satellites are, think of them of instruments that they're collecting data all of the time. If you can actually extract the information from them, it changes the workflow. So a city engineer might be used to doing surveying. We've all seen the trucks on the side of the road where, you know, there's people holding these surveying stations. They're using total stations, and They're getting one data point. They're getting very precise measurement over that one data point. But think about the impact of being able to cover the entire county of Tulare every 6 days. So now you can collect data points across that entire county on a regular basis. So there's huge savings in terms of, not having to deploy as many people in the field to collect the same level of data. And even just the availability of the data. They might not even know that this data source is available. Sure. So it completely changes the way that they can manage their infrastructure, whether that's bridges or roads or anything within the city that's of critical importance in terms of their infrastructure.
Perfect. Thank you, Kevin. I'm just going to ask one final time if there are any additional questions. If anyone would like to come off of mute, you can. If there aren't, just a special thanks, Dan, Kevin, for taking the time and sharing your advice and your wisdom and what you guys are doing. As an organization, we appreciate the time. So thank you again for spending time with us. This session again is being recorded and can be found on Cinchy TV. It should be up a little later on today. You will also get an email, a notification for those that are on the call with a link to it as well. Again, please feel free to share with your network, with your peers, if you find this information useful. And don't forget to sign up for our events coming up next month. They should be great.
I just have one final question.
Sure.
Can you hear me? It's Tom Kilburn from TCC. I'm just wondering, guys, because we see Cinchy is pretty unique in the marketplace in what it does. When you were going through your kind of analysis of solutions, did you look at any traditional solutions, and decide, hey, these don't even touch Cinchy? Like, what kind of category were you looking at when you found Cinchy and realized that this was something unique?
It's a good question. The industry has a tendency to lean towards open data cubes, and they've been around for a while. And I was aware of Cinchy because of a past colleague that I had in my background that now works for Cinchy. So I was aware of what was going on here, and I think it's a better fit. It does things for us that the open data cubes don't do. The keeping track of, but not having to have all of that data in one place, to be able to bring together the traditional and non-Earth observation and non-Earth observation data in a way that just really allows us the triggering and the ability to make relatively real-time data globally available. That was a big deal. Open data cubes work really, really well, sort of on a geographically contained area. Often you see them per country or per geographic area, but with Cinchy, we don't have those restrictions. And so there was just a little while ago an undertaking to basically say, can every country, or at least every major country, have a data cube, and then you could go there and get effectively the data for that particular country. But then if you're looking at global businesses, how many data cubes do I need to go to, and how often do they get updated, and who's in control of them? And it's a step in the direction of data centricity, but it's not quite there yet. And what I found Cinchy brought to the table, what we were looking at, was truly a data-centric model where we have basically one place to go at least for the planet.
Thanks very much. Impressive solution. I appreciate it.
Thanks.
All right. Thank you so much, guys. Okay. And thanks everyone for joining.
All right. Thanks again.
Okay. All right.
Okay.
Bye, everyone.
Bye. Thanks.
Yep.